Question 6, Part A, hypochlorous acid reacts with ethene to produce, I can say this is chloroethanol, in an electrophilic addition reaction. Define addition reaction. So in an addition reaction, we are looking at two or more reactants react to give only one product. Okay, this is a reaction where not just one, two or more reactants react to give only one product. They add into each other, give you only one. Then Roman 2, describe how chlorine is used to produce the hypochlorous acid dissolved in water. Okay, dissolved in water. When you get chlorine and you dissolve it in water, what you get is HCl and then this hypochlorous acid. That is what you get. Then this one is the one that has this, if you remove the hydrogen, so this ion here is the one that is responsible for the killing of the microbes in water or the bacteria. Okay, state one use of this. It kills bacteria. It kills bacteria in water, full stop. Then part B, complete figure 6.1 to show the mechanism for the reaction between the hypochlorous acid and ethene to produce this one here. Include charges, dipoles, lone pairs of electrons, and carry arrows as appropriate. Now, you realize that in our textbook, in the textbooks, we don't have this reaction here, okay? But we have a reaction between, now like this one is already charged, so it has the dipoles they are telling you here. Oxygen is more electronegative compared to chlorine, so it tends to pull the bonding electrons towards itself, thereby attaining a partial negative charge, and then chlorine attaining a partial positive charge. So the same way we do reactions, like if we have, let's say, bromine, you have bromine here, and then bromine, this one is not charged, okay? But then as it draws near this pi system here, electrons are negatively charged, so they will repel the electrons around bromine here, the one which is nearer to it. Then it will tend to have lost electrons, then it will attain a partial, or this one induces a dipole on it. That's why we say IDID, induced instantaneous dipoles, induced dipoles. So this one will have a partial positive, then this one becomes a partial, attains a partial negative, then this one comes to this, then this one loses, like that, and then we continue. So it's the same that we are going to have here. That means when we are bringing an arrow from here, then we bring it to the side here. I'm going to bring it to this side here, which is positively charged, because this one, the pi system here is negative, okay, negatively charged, because there are electrons in there. Then they have to be donated to the side that has the positive charge, you see, and then this one will break off. So meaning we are going to have H2, then I'll have CH2, then Cl. Based on the structure here, you put the chlorine on this other one here. Now, the pi system here has lost electrons, so this one will have a positive, okay? Now, this is the intermediate. An intermediate here has a full mark on its own. So if you don't put this plus here, you're going to lose the marks. you're going to lose that mark there. Now, when this one breaks off from here, we are seeing it becoming negatively charged completely, okay? And then you put a lone pair here on the oxygen, and then you give to this carbon here. Then it will come here as the OH here, and that will be your final product. But see, chloroethanol reacts in a two-step synthesis to produce the ethanoic acid here. We are seeing this is not ethanoic acid. But see, chloroethanol reacts in a two-step synthesis to produce, I can say, carboxylic acid end here and then an alcohol here, okay, as shown in this figure. So the first thing, you can see that these are two carbons, but now here we are seeing three carbons. So we have to increase the number of carbons by introducing, let's say, potassium cyanide. So when we put potassium cyanide, there is going to be a substitution reaction, and that potassium cyanide has to be in ethanol. Then the chlorine here, the halogenoalkane, is going to turn into a nitrile, okay? Then after that, you put the HCl, and then you hydrolyze this one here, it becomes a carboxylic acid. Okay, so they are saying Brahman 1, state the reagent and the conditions. So this one, the reagent has to be potassium cyanide in ethanol. In ethanol, and we also have to apply what? Heat. Now you can write potassium cyanide in ethanol, but if you don't put heat, you're going to lose that mark, and remember it is one mark. So that's why in the marking schemes, you find when they put and, it is bold and in capital letters. So meaning there is an emphasis there. So you have to put the what? The heat. If it is not there, then you lose that full mark. Okay. Then next, identify the type of reaction that occurs in step 2. This one here. That is hydrolysis. Hydrolysis. And when you hydrolyze this one here, the nitrogen, when it gets off from here, where does it go? So you get an ammonium salt here. So if it is HCl, then you get ammonium chloride. Very important. Roman 3, complete the equation to show the reaction in step 2. This is where we are going to actually write that. So when we write HCl, when you are hydrolyzing this one, you put the HCl there, and you also put water. Okay, you also put water because of why am I putting water? Because we are going to need the oxygens in here. So now if you just put, let's say, the HCl here, it might not balance well. So you put the water, and then we can now write this HO, CH2, CH2, COOH. Then we can put the ammonium what? Chloride. Ammonium chloride. So that is what we are supposed to have there. Then maybe we can balance and we see how many oxygens do we see here. These are 2 plus 1, those are 3. This is 1 here. That means I will need 2 here. So if I put 2 here, I think we have balanced. Hydrogens, how many are they? These ones are 4. Leave the hydrogens here. They are here. So there is 1 here. Then plus the 4. Isn't that a 5? So these are 5 here. Then there is also 4 here plus the 1. Those are more 5 added. So I think it is balanced. Yeah, it is balanced. That is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.